Good morning, ladies and gentlemen, Precalculus. Yesterday we went over problems 39 and 40, and so we're building upon that today with 41, 42. So I'm going to go ahead and just help you talk me through 41, and then I'm going to choose somebody to do 42. So here we have, we're going to state the degree and list the zeros of the polynomial function, state the multiplicity of each zero, whether the graph crossed the x-axis at corresponding x-intercepts. Now, two of our students were not here yesterday, so the way we're approaching that is to just work on that. So the first thing we're going to look at is stating the degree of this function. So we look at problem 41. What is our degree of this going to be here? Okay, I heard someone who said 5 there. Is it Chloe? Okay, 5. How'd you get 5, Chloe? Yeah, so the 3 and the 2. So if you multiply x, she says, if you multiply x cubed and x squared together, you're going to get degree 5. Is this going to be a positive or a negative natured function? When you look for x, do you see negative x anywhere there? So this would be a positive natured, and that's not what it asks, but that's what's going to help us in the graphing of this. And then what are the zeros of this function here? Zeros.
Negative, positive 1.
So x equals 1 is one of the zeros.
With multiplicity.
Okay, with multiplicity equals 3. And then is this going to cross or not?
Yes.
Yeah, crosses, because it says whether or not crosses the x-axis, crosses x-axis. Okay, and then where's another zero? -2. X equals -2. Okay, and is this going to be, what is our multiplicity of this?
2.
So multiplicity equals 2. Is this going to cross or not?
No.
Not cross x-axis. So then it says, so that's all of these things asked for. And next we're going to sketch the graph, and I'm going to mark the zeros on the x-axis. So here we have x equals 1, that's one of our zeros, and x equals -2. So this one here, degree 5 and positive, what is that going to look like? Is that going to look like this, 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 or this? Option 1, option 2, option 3, or option 4? 1, 2, 3, 4. What is that going to look like? 4 is like this, start low, end low. Option 1, 2, 1, you say 1. Everybody see that? Start low, end high. Start low, end high. You see that? Odd, positive, odd, positive. So let's go ahead and do that. So we're coming from, so we know we're going to start down here and we're going to end up here someplace. So we're going to come here, and then as we approach, we ask ourselves, we're approaching x equals -2. Is that even number or odd multiplicity? Even. So are we going to cross? No, we're not going to cross. So we're going to come up here, and then we're going to go now. Over here as we approach 1, is that going to cross?
Yeah.
And what tells you it's going to have to cross besides multiplicity being 3? Where's the end? Where do we have to end? So doesn't that tell us we have to cross?
Yeah.
Since we end. And if you graph this, in a calculator, you'll see something that looks like that. Is it going to look exactly like that? No, not exactly. Did anybody graph that in the calculator? If you did, you would have seen it, right? I like graphing these things in the calculator that we do because it verifies our analysis. Oh, degree 5. I'm going to leave this up here. Okay, so that would be number 41. Did it look the same, Riley? Pretty well? All right, good deal. What I want you to do is go look at 42 and work on 42, and I'm going to randomly call someone in the classroom to help us out with that. How's that? Go ahead and get a little bit bigger up here. Okay. Go over here. Okay, see this. Okay, I'm going to ask for one of you to help me with this one here. And let me just do a little shuffle here. Who's going to be helping us today? Oh, Chloe's going to be helping us. All right. She'll be up to the task. Okay, Chloe's going to, for recognition, help us with this. And she helped us with the other one too, so that was really good. She's all ready. Right, Chloe? You're ready for this, right? So the first thing we're looking for is degree, right? So what will be our degree of this thing? 6. Now not that it asks here, but is this going to be positive or negative? Positive. So positive. Okay, now we're gonna go ahead and accumulate our zeros. X equals 3. I'm going to write down here x equals -5.
Multiplicity 2.
So this one here, multiplicity equals 2. Crosses or does not cross?
Does not cross.
Okay, doesn't cross. X-axis, okay. Okay, this one here, x equals -5.
Multiplicity of 4 that crosses.
Multiplicity equals 4, crosses. Crosses. X-axis. Okay.
start high and end low.
Start high and end low. Let's look at this. Does everybody agree with that?
No, start high and low.
It's gonna do what?
Wait, starts with,
You don't know?
I guess it's gonna start low and
Okay, let's
then.
talk
Start
about,
high and low.
okay, degree 6, even number or odd number? Even, right? So it's gonna be either even positive or even negative. Here's even positive, here's even negative. Which is this? So where's it gonna start?
Odd and then low.
Where's it gonna end? Even positive starts
High,
and ends
high.
high. Okay, so now, let's go ahead and graph. That's the beauty of this thing here. Okay, so we have x equals 3. Yeah, we have x equals -5. And 1, 2, 3, 4, 5. And we're going to start, and we're going to end. And so we start, we come down here, and at x equals -5, are we crossing the x-axis? Well, it says crosses x-axis here. Is that right? Okay, so we cross x-axis, and then we come up here, and then this one here, x equals 3, do we cross the x-axis? No, we don't. So we end up down like this. Does that make sense? No. What's wrong here? Something's wrong.
It crosses at 3.
It crosses at 3. One of these things is wrong. The crossing has us messed up.
Crosses at 3.
It crosses at 3? But then you would say this crosses, then they would both cross to have that happen. Riley's nodding head. What's happening?
Neither of them cross?
Okay, Riley suggests that neither of them will cross. Let's try this. Okay, so at -5, if we don't cross, it's going to go like this, and come up here, and then at 3, do we cross or not cross?
No.
Not cross. So we're going to go up like this. Yes, because, and that's the thing about this, if you analyze properly, you catch your mistakes. Because here we had does not cross, but this one also does not cross. Did anybody graph this with a calculator? Did it look like that? Yeah, this is really a weird one.
Just went down and then across all the way and then up.
Yeah, let me show you this in the calculator, because the calculator, the dimensions of the calculator make this hard to fathom. So if we go over here, and, well, there it is. We have 7, let me get here, 7 quantity. We have x minus 3 squared. And then that's going to be times x plus 5 to the 4th power, to the 4th. And we graph this thing to standard window. Looks like this. Okay? Don't see anything, do we? We see this one, And that's fine at x equals -5, but we're not seeing this thing over here. Why not? I'll show you. The reason is the dimensions of the graph really take off, because you see we're going to have our y-intercept is going to be 7 times -3 squared times 5 to the 4th power. And I'll show you what that looks like. 7 times -3 squared, which is 9, times 5 to the power of 4. And so we get, this is going to be our y-intercept right here. Okay? So our scale makes it so we can't even see the graph of it when we graph. So that's why. So if we change the window, we should be able to see that better. And if we change this, we know our y-intercept is 30-something thousand. So I'm going to make this 50,000. And then our y-scale, I'm going to make it 10,000. And I hope we can see it better now. Okay. Does that look better now? And so what happens when you had the regular standard window, the resolution didn't even pick up this little dip down here like this. And we can even see a little better with the window if we make this y minimum maybe -10,000. So we should be able to see it even a little better there. You can see the bounce and the bounce. Okay? All right, does that make sense? All right. And so, does this tell you that really in the calculator, there's some things the calculator is not going to be able to pick up? Yeah. Okay. Let's go on to, Chloe, thanks for working with us on that. That was good. I'm going to give you credit for that, okay? Being in class, working hard. Okay, we have 49 through 52. Find the zeros algebraically or graphically. What I recommend on these is trying algebraically first, see if you can do that. If not, as a final resort, we can use graphically. That's my recommendation on these. What would be your strategy on this one?
Completing the square.
Completing the square?
Oh yeah, that's what it is. That's what
So what's a common factor of this thing? X times,
X minus 6.
okay, and then what else?
Negative factor down there, go X times X minus 6 times X plus 6. Yeah, that's what I did.
Okay, Elizabeth, that's good work. What?
X equals plus or minus 6.
X equals plus or minus 6, and X equals 0. So where, do you remember when it was, Elizabeth, you learned that factoring technique? This factoring technique, the difference of squares, where it was you learned that?
Oh, I don't know.
You just knew how to do it. You remember when you learned how to do it? You just,
I learned to do it
at some point in her math career, right? So these would be our zeros right here. Okay, and again, this is one where algebraically it's really not too bad. So I want you to go ahead and look at number.
How did you get 0? You said it equals 0. You
So
Yeah.
f of x equals 0.
So yeah, you change this to 0 to find the zeros. I didn't put that here. So the strategy is that you set, to find the zeros, you substitute 0 for f of x and then solve the equation, and that's how you get it. Does that make, is that okay? All right. Let's go on ahead here. I want to choose somebody for number 50. The 50, 50 is more complex. So something that's there that we haven't done, I would suggest graphically. 50, yeah, so I would just go ahead and graph this. When you graph this, where are you going to see the zeros?
Where's this error?
It says error?
Right, that's what it is. Where x, or y equals 0? Oh, yeah, where y, no, where x equals 0. Right, because x equals 0, that's,
No, find where y equals 0. What you're doing is you got a cubic function here, and I don't know exactly what it looks like, but it looks something like this. It's going to look something like this, and you're going to see x equals that value,
Mr. G, we're on 50.
that one. Okay, 50, sorry, got the wrong one. Probably similar. Yeah, this is very similar. Okay, that drawing I made for 51, same thing. So I'm going to go ahead and call for a victim here on this one too. It's going to be Riley.
That was that.
Okay, Riley, did you find zeros on this thing?
At one part where y equals 0, x is 10.
Okay, so x equals 10 is one of our zeros.
Yes.
Okay. Any other zeros that you discovered?
-1.
X equals,
So that's -1.
x equals -1. Any others? See, I'm thinking if those two are zeros and it's cubed, you're going to also have maybe 11, negative 11. X equals -11. So is that what you got, Riley, for that? What is hard about this one? I know what's hard about it. What is hard about it? Tell me. Is this thing here in the standard viewing window?
No.
No, it's not. Okay, so you graph a standard viewing window, you're not going to see it. But I want to do this for thoroughness of the audience. X cubed plus 2x squared. X cubed plus 2x squared. And that's going to be minus 109x minus 110. And graph zoom 6. So we see is that right?
It is, you just have to, you have to fix the window. I don't know, it looks weird on a standard window.
Okay, that's right. So let's go ahead and fix that. I'm going to fix this in a couple different ways. I'm going to go to -12 to 12. And I'm going to go like negative
500.
-500.
Probably one I put 450.
I'll put 500 again here. I'm going to go by maybe 50s. Graph should see it pretty well. So here's the negative 11, negative 1, and 10. Negative 11, negative 1, 10. There they all are. Okay? What does this end up being kind of an exercise in doing as much as anything else? Yeah, using your calculator, right? Manipulating your calculator to find this. So I want to get another participant, if I could, to help out with 51, and it's going to be Justin. All right. Justin, you have that figured out here? All right, Justin, you have zeros? Not yet, still working on it. You could actually find zeros for these algebraically, but to do that algebraically, we have to introduce tools that we're going to develop shortly in section 2.4. Justin, what do you got? So x squared, it's going to be minus 49x plus 55, 40. So it looks something like this. Yeah, see, Justin, you have zeros for this? Okay, let's take a look here. I just graphed this in the standard window. Here's a standard window, zoom 6. And I see a 0, x equals, where's this thing hitting? One, two, three, four, negative 5, 1, x equals 1, and there's another 1, 2.
It's 11.
11? Yeah, let's go ahead and take our window. And then we can change our I'm not sure exactly what's going to work for this. Yeah, so that works pretty well. Negative 5, 1, and 11. So these would be our zeros here. Okay. And our very last problem in this set here, 51, 52. We don't have a lot of candidates left. It's gonna be Karina. Karina got chosen again.
Virgo got lucky.
Earl left. Yeah. Okay, Karina, what'd you get for this?
-6 to 8.
So x equals -6,
Positive 2.
-6, 2, and 8, you said? And that was just graphically you determined that. It's pretty easy to do. Okay, really good. We got, I want to get you started on something else today too. Starting with here, 4, then we'll go to 11. And I don't know, this is a quick review, I don't know how far we're gonna get on this today. We may not finish this thing today.
Yeah, here's.
Yeah, you have your deals here. I give you extra paper, just what you need. Okay, 5 right here. Let's see if I have it here. No, I don't have it up here. Chapter 2.4. There we go. Okay. While that's loading, I want to erase this, make sure I have this out of here. Oops. Okay, here we go. Okay, we have rewrite expression as a polynomial in standard form. And what we have here is we have x cubed minus 4x squared plus 7x divided by x. And so what we have is x is a divisor to each one of these separate terms. So just rewriting this, we're going to have x cubed over x minus 4x squared over x plus 7x over x. And what happens to x cubed divided by x? What is x cubed divided by x? X squared. And what's 4x squared divided by x?
4x.
4x. and then 7x divided by x
7.
plus 7. And so this is our standard form of that. So that is our answer. Okay?
We're not going to do the spin to see if we test it.
Oh, you want to spin? Want me to spin? Okay, let's do the spin, yes.
Oh, we've already done the last one.
Oh, okay, yeah, because we're out of customers pretty.
They were restarted for the last time.
No. Well, I think we'll go and get everybody in here. Why not? Then we can start after that. But we're kind of getting short of class time too. I don't think we'll finish everything here. So we'll get Robert. And so okay, so Robert, what do you have here?
You're the one that wanted to spin.
Square.
So what did you get for this? X squared?
And then 5 2 x
Okay.
7 over 2x and
Okay, this is what Robert did. Did you just do it mentally?
yeah.
Okay, Robert said he just did this mentally. I think that's correct, but just to validate here, I'm gonna just rewrite this as 2x cubed over 2x minus 5x squared over 2x and minus 7x over 2x. So you can kind of see what happens here. The 2 over 2 cancel, and x cubed divided by x is x squared. And here we have one of these x's, this squared cancels out this x, so we have negative 5/2 x. And then finally, we take x over x, so this is going to be a correct answer for us. All right? Are we pretty good with that? Chloe, how'd you like playing volleyball yesterday?
That was terrible.
Why was it terrible?
Because they suck.
Oh, the other team?
Yeah, Kim.
Well,
And I did not want to play.
they had a couple players,
No,
but
no,
not really.
no.
They scored some points off you.
Yeah, that was our fault.
Yeah. Okay, number 3, we're gonna have, now it's gonna be for number 3, it's gonna be a big surprise on whose name I spin here. I wonder who is,
It lands on the line.
yeah, that's a lot.
Oh my gosh.
Removed, and so now we have no one. Okay, Elizabeth, did you get this one?
X squared minus 3 plus 7x cubed.
Minus 3
Yes.
plus
7x.
7x cubed, is that right? Is that right? Well, what they did is they threw you a curveball, Elizabeth. And the reason they did is this. So let's just do a rewrite of this, because I think otherwise it's probably,
Maybe it's negative 7x cubed plus squares times 3.
Plus x squared.
so what you'd have to do is just rearrange these in order, right?
Just put
And
it-
what's the next one here? Plus
Plus x squared minus 3.
minus 3. And now are we in standard form? Yes, we are. And then, so, thank you, Elizabeth. And then we have just because it'll be to just finish off this section. Let's do this one here. Should we do another random name on this
Yes.
one? Yeah, let's do a random name. We'll have to get a new wheel on this one. So I'm going to do open. It'll be open 5th period again. And here, we'll just do a random name.
Who's mine? I'm leaving.
It'll be Elizabeth.
said, watch it be me again.
Okay, Elizabeth, you get another one. Okay, Elizabeth was neglected, now she got 2 in a row. So Elizabeth, you can go ahead and do that one too. Well, Elizabeth on the hot seat. At the very end of class.
So
It
that's
tested her perseverance.
2x squared minus 2/3 x plus 2 and
Big ball.
All of a sudden, embarrassment riches. Go ahead, Elizabeth, I missed that again, go ahead.
2x squared minus 2/3 x plus 2 and 1/3.
Plus 2 1/3, I'm gonna call it this. I'll call it 7/3, how's that? Is that what you meant, Elizabeth? Is that right? It is, okay. So this will be correct also. And we're just gonna leave it there today. Thank you for participating in class.
Do you want the paper or no?
Yeah, the one you already finished. The other one